idea first came up offering virtual reality programming. Is I went down to Best Buy and I'd mentioned I'd take my son to that one place, the Fireshark Gaming, and they loved it. And I went to Best Buy myself, but put one of those Oculus headsets on, and thought it was the greatest thing ever. Um, just a realistic, just the being immersed in that environment was fantastic. Um, Came back and said for the administration because they were wanting to know where can we go in and be interesting for students. Yet they would still learn, programming skills that could help you in many IT careers. And so I came back and said VR is where we need to be, virtual reality. And then I went back to Best Buy and trying to decide where should it head because there's a lot of technology out there on it. They had the Oculus set up there. They had Microsoft's. Microsoft has a form of the virtual reality, and I'm sitting there going back and forth between them. I can't really decide because I knew from my research the Oculus had been around forever. Um, I also know that Microsoft they have pretty good support, so they're going to be around for a period of time. But I also kept in mind that sometimes Microsoft just abandons products. If it's not making enough money for them, they just throw it to the side. Doesn't matter if a lot of people have developed for it, then it's gone. Not saying Microsoft has thrown theirs to the side, though I haven't looked for a while. It's like Microsoft Mixed Reality or something like that. Microsoft Mixed Reality headset. If you come here, they'll talk about their. I'm not sure what in the world they're doing there. Maybe you have to have some kind of device on your head. They talk about how they're evolving it and so forth, so they haven't given up on it. But you will not find it. At least I think it was 6 months ago when I looked. There was no longer in Best Buy, and they indicated that just the demand wasn't there for Microsoft's product. So I was kind of glad that it chose Oculus. What they're talking about here is a little bit about the history. This is out of the book in chapter 1. Now we got the basics of programming, basics of Unity down. Then we're going to get into talking about some of the aspects of virtual reality. You may not have the Oculus set up, and don't panic if you don't. So I won't assign you anything specifically that you have to have that set up if you don't. Um, but and I thought this was really interesting when I was reading this. Has been a niche market since the early 1950s. I wasn't quite sure about that. And I'm not sure when the computers have really been taken off, but I'm sure they're not talking about computer based. So I thought that was interesting. Um, it could be just trying to make things look more realistic, where you use models. Uh, Godzilla, maybe. I don't know what they're referring to. Where you have more of you create a model and it looks more realistic. This
Uh,
goes over the details of Oculus and so forth. Talks about everything the chapter is going to cover. Um, Concept of virtual reality. You got your head-mounted display, so it's a little bit different. You're not sitting there pressing buttons. You're not pressing the A, S, D, and W. Some cases, maybe you just turn your head, and that's causing the camera to change, for example. They also got those, depending upon which model you have. I have both at home, and I have lots of the full Oculus Rift here. But they got those little holders you can do in your hands. And I'm trying to remember that portable one, what it has for your hand. I guess I haven't played it for a while. Um, hmm. HMDs, such as Oculus Rift, are typically treated like an extra screen attached to your computer, but with some extra components enable it to capture its own orientation and position. Essentially, because you can maybe be looking down. So lots of different ways you can rotate and do that. Essentially mounts to a screen, sits on your head, knows how it moves, so it can mirror your head movements. Now, the nice part about that is we're going to find we don't have to program all that into Unity. There's libraries that'll help us and so forth on that. Here's your picture here, and this kind of demonstrates the different terms. Pitch is going around the X, and the roll is going around the Z, and then you got your yaw, if I'm saying that right, around your Y-axis. So if you hear them refer to those definitions, that's what you're talking about. Depth perception is another big principle of virtual reality, because a display of the HMD is always positioned right in front of the user's eyes. The rendered image is typically split into two images, one per eye, with each individual image rendered from the position of that eye. You can observe the difference between normal rendering and VR rendering following two images. First image is how normal 3D video games are rendered to a computer screen, created based on position and direction of a virtual camera in the game world. So we got that right there. Next image talks about the virtual reality, because you got your left eye and you got your right eye. And you still got your object there. Limitations of VR games. There's some warnings I have here. I didn't really like this concept right here. Has anybody ever got sick from VR?
Not from VR, but from other things I have.
Oh, okay.
I've never been motion sick in my life, so.
Well, my big idea, and I talked about this in the last class, is I bought these headsets, the brain interfaces, with some games to go along with them, and I thought about asking the college to buy those portable Oculuses. Is it Oculus Go? I think.
Yes, that is it.
And I thought about buying, 2 or 3 of those so I could take them to like the homeschool conference, the state fair, different locations, and get people excited about computers. Then I was reading about people getting sick, and from the virtual reality world, or even passing out in some cases. It's just, ooh, I don't think I want to deal with that. And have some lawyer contacting me at Cali as they banged their head on the table. So I may never get to that point, but can cause some people to feel a sense of sickness. Talk about inner ears accustomed to sensing inertia. We move from place to place. So if you were to push your joystick forward to walk in VR, your body would get confused when it senses that you're still stationary. I've never had that issue when I played, but like I say, you haven't either. Typically, when there's a mismatch between what we're doing and what we're feeling, our bodies assume that a nefarious poison or illness is at work, and they prepare to rid the body of the culprit. That's the motion sickness you feel when reading in a car, standing on a boat, and yes, moving in VR. Okay, that doesn't mean we have to prevent users from moving in VR. We just might want to be more clever about it. And they talk about that later on. So there's a lot of considerations you have to take into account when you're throwing somebody in the world. Talks a little bit about here primary occurs in nausea and so forth. Brain gets confused easily. Lack of real-world vision. One of the clumsiest aspects of VR is getting your hands where they need to be without being able to see them. And that's sometimes a challenge. Because you can see your hand moving up here and so forth, but then how do you simulate that in a virtual reality game? Usually when your hand comes up, you see some kind of shadow. Well, in some games, you see some kind of shadow of your arms, looks whitish or something, and goes up. Okay. This talks a little bit about AR down here. It talks about the VR headsets. Oh, and I want to talk about that also. How Microsoft is no longer being sold to Best Buy, which puts a big damper on their market. I think when they lose the Best Buy angle. But if you go there and look, you'll find lots of cheap devices for your cell phones. And I asked them about those and how come there's so many different ones and so forth. There's one that's better than the other, and his comment was they seem to come and go. There just doesn't seem to be a leader like Oculus that's just stuck around and had the market share. That's been a while ago. That's probably last summer, actually, when I was talking to him about that. Probably the beginning of summer, May, June. So things change. Anybody got one of those for your, those cheap ones from Best Buy for your phone?
No.
I have not.
Like I say, I don't know what they're really like. Note, even before modern virtual reality, developers were creating applications that overlaid smart information over what a camera is seeing. That's called augmented reality, AR. Experiences a right line between camera output and virtual environments are called mixed reality, MR. And it talks about unnatural head movements. I thought about it before, but looking around a traditional first-person shooter, FPS, is quite different than looking around using your head. The right analog stick is typically used to direct the camera and make adjustments as necessary, but in VR, players actually move their head instead of using their thumb to move their virtual head. Don't expect players in VR to be able to make the same snappy pivots and 180-degree turns on a dime that are simple in a regular console game. I made the comment one time about that I would never like PC games, versus my PlayStation, because using the keys to rotate, to move around, and so forth, I just wouldn't be that quick. And some people indicated that they believe that they have faster response with the keyboard. I don't know how that can be. To me, it seems like if you got a joystick, that's your fastest response. But again, things you have to consider.
Normally, you use the mouse when looking around playing a PC game.
Oh, okay. So they mean a mouse provides better performance than a Sony PlayStation. Do you find that to be true?
It really varies depending on what game you're playing.
And who you are. If you're more used to circular motion with your wrist instead of your thumb, you might be better on mouse than joystick.
What I'm really interested in playing with over spring break is I want to see if I can see if there's a way to put, and I haven't even read about it yet, to put a Unity game on a PlayStation or on a Xbox.
You can do it to a PS3, but it requires a special device that you attach through the USB port.
Oh, okay. You can't do it on Xbox at all?
Not that I know of. I just know about the PS3 because I already looked into that.
Oh, okay. Yeah, that's the part I want to play with is I mean, I'm not to sell to people, but I'm just talking about for testing purposes. Because I'd like to see actually something I create on a PlayStation, for example. I was curious last time about that HTML5, and I went and installed libraries for it and everything. And sure enough, you can put a Unity game on a website. Um, I don't know what kind of performance you'd get running it off of HTML5, but I found it fascinating you could do that. It talks about another limitation to consider when designing your VR game is what's called vergence accommodation conflict. Basically, what happens when distance, the point of your focus, or vergence, that is an object in VR, is notably different than your focal distance, or where your eyes are actually focusing on the screen in front of you. This image from a research article in Journal Vision demonstrates a conflicting difference. Here we got just what we see in our everyday lives, our real world. And then we got our visions here. And we got that focal distance is the distance from that object in the real world to our, here's like I'm guessing I don't know anything about anatomy. What am I even saying? But it doesn't look like it's the very beginning of your eyeball, but maybe inwards.
It goes to the cornea.
Cornea? Okay. It's been 30 or 35 years since I've had biology. And then your vergence distance there. But over here, when you have that display screen here, then you have your 3D display here. So you got a difference between those two distances. Forcing the eye to focus on objects that are too close or too far away for extended periods of time can cause symptoms of eye fatigue, including sore eyes or headaches. Therefore, it's important to consider placement of the pieces of your game that will draw a lot of attention. So the design, where you may not have to think as hard on the 3D game development, you have to think more about where to place it at. How many of you got an Oculus Rift?
And no, I don't.
My brother has a cheap one for his phone that he doesn't use, but it's not compatible with anything else. It seriously has a slot that your phone goes in.
Oh, yeah. It was a challenge because I got all excited about that, and I had saved up some money from some tutoring I had done, and I went down and I bought an Oculus Rift, and I thought, well, fantastic, because I have a fairly new computer at home, and I got home, thought I'm gonna be playing my Oculus Rift and having fun and so forth, and then when I went to plug it in and set everything up, it expects to plug it into your graphics card on the back of your PC. Turn my computer around, I'm looking, and it's like there's no plugins on my graphics card, and I didn't even have a great PC in terms of graphics, so that was kind of upsetting. And so then I thought, well, that's great. I bought this expensive Oculus Rift I can't use, and then I did some more tutoring for a student out in Colorado. I did it online, and eventually got money to buy a new desktop. And so I went down there and I got one that would be compatible and so forth. So I can now play it on my desktop, but these little tracking devices have to be positioned in the right places. And my little computer room's too small for those, where they need to be. So it's just been interesting dilemma after another on that. Looking back on it, I should have got a gaming laptop so I could go out to the kitchen table and do it. I told him what laptops I wanted here. I picked out some of a pretty good gaming one. Said this is what I want. Even looked pretty cool. had like the red coming off the keyboard, if you've seen that. Not that that matters, but they wanted the lab to be innovative, to stand out among every other computer lab across Kansas. And I thought, well, if you had 10 laptops open in here and they all had the red coming off the keyboard and you had the lights kind of dimmed, I thought that'd be really cool. Somebody coming by and looking in.
Well, put a bunch of LED lights in.
Yeah, that would be that's probably what I should do now. But didn't get those laptops. Ones they got are these ThinkPads, and they're not 100% compatible with the Oculus Rift, which I wasn't exactly pleased with when I plugged in the equipment. They still run. Don't get me wrong. You can still run the games. You can still develop games for it and so forth. But it just doesn't have the same specifications that a gaming laptop has. But that's what that is tracking. So it's going to help track your movements. Okay. Let's see. Early in the chapter, briefly mentioned that HMD sometimes monitor positional movement as well as rotational. There are a few different methods of tracking HMD positionally, but so far every solution includes an external component not connected to the headset. In the future, as the hardware gets better, we can expect solution to positional tracking as part of the headset itself, referred to as inside-out tracking. The Oculus Rift solution to positional tracking is called constellation tracking. It uses an infrared camera that faces the user to detect small infrared LED markers. And I wish I was just a little bit better, because you just have to have it just in the right place for it to detect everything. And then extrapolate positional movement values based on number of pixels those markers move in a frame. Here's what the tracking camera looks like. And again, it's got a cable running off of it. So you have a lot of cables plugged in. As long as the Rift's in the view of the camera, the user can laterally move their head, and HMD's display will update to reflect it. This can be used for mechanics such as leaning into or understanding something or sticking your head out from behind a corner. And it really is amazing when you get it set up what it does detect as you move around. Constellation Tracker is capable of tracking a Rift in a seated or standing experience, which means you could even engage a player in limited full body movement. Oculus Touch controller shipping in late 2016 will include an additional camera to improve the quality of tracking further. At that Farshark Gaming, you stood for some of them. They did have some where you sat down and played them, but you'd be like swinging around, lightsaber type of deal, a sword, and they had wires on them. It had sensors to tell you when you went beyond. It had those tracking like you're seeing, and when you went beyond that square, then it notified you. Because the problem is when you got that on, you're completely oblivious to anything that's going on around you. And so if you don't know what you're doing, you can move across the room and smack somebody else with your hand or with that device. So that's built in with that system. This is an image of an earlier Oculus Rift prototype that shows the exposed IR trackers tracking the outside of the device. Okay. Generally, the more realistic the VR experience is, the more the user forgets about the world outside of it, and that's true. You can get lost in it and not realize what you're doing when you start, flailing around. Positional tracking adds a lot of realism to the feeling of looking around in VR, so it's a good idea to design your game in a way that will take full advantage of it. You look at some of the games in VR, maybe some of you played, and some of them are not so great. The graphics is just maybe so-so. The mesh objects just so-so. But it doesn't matter because it's brand new. You're immersed into it, and so you don't have to have as a high of a degree of quality as you would in a normal game off of your PlayStation or your Xbox. So that's interesting when you look at some of the games. Doesn't mean it's not going to get there eventually, but some of the first ones aren't what you'd think. Haven't really talked about the controller yet in the 3D game development class, or in this class, because I haven't bought an Xbox controller to plug into the for the class. I need to do that. That's one of the things.
If you hit up the Walmart in Goddard, I think they're like $30. So
really, I could probably afford that.
Cheap.
Seems like the last.
There's some that you could get pretty cheap online too.
Can you? Yeah, some of the last PlayStation one I bought, that seemed like it was about $50 or something. And yeah. Let's see. Out of the box, you'll have 3 possible solutions for controlling your game: the Xbox controller, Oculus remote, or your keyboard and mouse. Once Oculus Touch controller is mentioned in the last section released, you'll have a much more immersive way. And this is a little bit old. They've been released. And they're a pretty cool way. I never used a controller or anything. So that's outdated. Okay. Added ability to track in the user's hands, just like the Rift headset is tracked. I don't what is it? Let me look for a picture of that. Oculus and controller. If you haven't had exposure to it, that's what it looks like. And you put them on your hands there. They kind of go around like that, and then you can use your thumbs. I don't think fingers. It's been a while. You can then use that to control these knobs here, so you can fire, so forth. I should have pulled one of those up before class. But it's not only that, it's not like a fancy joystick or anything. It's the fact that you move and it senses the movement of your hand. I'm trying to remember the Oculus remote. Maybe that's just the old, because I don't think I remember a remote. Okay, if all else fails, you can use a keyboard and mouse, but if the keyboard is complicated and somewhat restrictive, you should always look to simpler input methods since you have a stronger reasoning. And again, since they came out with those new controllers, then it just makes it that much easier. Importance of frame rate. Drops in frame rate are much more acceptable outside of VR than in VR. If a computer is good enough to run a game at 30 frames a second, but not at 60 frames a second, some players are able to push through it and get accustomed to the lower frame rate. After all, we watch movies at a frame rate, sometimes even lower than 30 frames per second, so it's not unreasonable to think that a game at 30 frames per second would still be enjoyable. I'm trying to think of some game I played where it reached the point where it's just unplayable.
Any online game with bad internet connection?
Yeah, that's what I was thinking about. That was that big one that was out at one point in time. Um, oh, it's almost like a not a Dungeons and Dragons type thing, but along those lines. Um, what is one of them out there that has like wizards and elves and all that? A big one.
GURPS, D&D, Warframe.
World of Warcraft. Anyway, that's one I bought. I bought that for my son's computer, and the frame rate, again, it wasn't that great of a computer, so the frame rate was such that it became unplayable. So you can get by with a little bit, reduction, but when you're right, when you're doing that internet based and you got that, it's just horrible. At this point, my son was that was a Christmas present, and probably just as well. Suboptimal frame rates are much more important when it comes to VR. Since HMD takes over entirely what our eyes see, it needs to update the world virtually as quickly as our eyes could. If the world we're perceiving doesn't update as fast, we look around it, our brain starts to get confused again and cue the nausea. Sometimes referred to as VR sickness, and not only does it decrease the feeling of immersion a player gets, but it can also leave them feeling ill after removing the headset. When I talked about these laptops that they bought, weren't the ones that I picked out, and I said they're not quite what they need to be. That's where maybe you get it. You'd have a reduced frame rate, and if you played it for a long period of time, you might start feeling sick. Talked about the hardware. You can update the display with a new frame rate up to 9 times a second. While 120 times a second would be ideal, the steady frame of 90 will be adequate and mitigate the vast majority of nausea. It'll get there eventually, where it doesn't cause people to get sick, maybe. Talks about really complex, asset-dense games require a large number of calculations. Every frame can start to have a monopolistic impact on a computer's hardware. And this is part of the reason now maybe why you see some of the games is simplistic compared to some of the other ones, because they don't want to overload it. One of the games that I played was a ghost game, an Oculus Rift. It's where these ghosts would come out at you, and they come out at you in droves, and you're to fire at the ghosts and so forth. And it was very cartoonish like. The meshes weren't something you'd think, oh, that's real life. But again, the fact you're in that immersion is what made it great. Okay, talks about sporadic frame choppiness known as judder is one of the fastest ways to induce VR sickness. First chapter should almost be about there's 10 chapters we're going to cover total on here. But this first chapter should almost be covered besides the basic terms that you'll run across, but also about the dangers of being sick with it. Okay. Good news regarding high performance costs of the Oculus Rift. You're not without help. Asynchronous time warp, ATW, is a rendering technique that helps fill delays in rendering with a calculated intermediary frame. In a sense, ATW warps an image based on the user's head movement, giving an appearance of multiple rendered frames, but actually only modifying one while the rest are generated. All rendered images need to be warped at a baseline level so they don't appear skewed when viewed through the lenses. So adding an extra step to the warping process is relatively inexpensive for your hardware. ATW can go a long way in making up for lost time in your VR experience, but it's important not to rely too heavily on it. Because like every other rendering trick, it has its limits. For instance, with purely rotational ATW, the user can experience a positional judder, which causes objects close to the user to appear blurry or doubled noticeably. This gives you a screenshot of a submarine interior provided by Oculus, demonstrates the perceived effect of positional judder. And it's kind of small, so you can't really see it too well. But do you see how it's kind of got that blurriness?
Yeah.
ATW calculation is relatively simple because they only take rotation into account. Lateral movement is an entirely different problem. 2016, Oculus announced work on a complementary feature called asynchronous space warp, which perform predictions for head positions as well. And some of this I haven't, some of the newer I have not played with because I've downloaded the older toolkit they have on here at home, and that's one I played with. None of you have an Oculus, so I'm not going to talk about the installation there. And then there's summary. That's the end of chapter 1. This talks about a little bit about working with Unity and VR and so forth. So let's take a look at that. You install Unity, of course. This talks about different components that you can install. And creating a project here. Hello VR. Make sure a 3D option is selected, and this looks a little bit different than our screen. Then you get into the editor. That's our standard 3D. A lot of this we'll skip over because we're kind of already been talking about it a little bit. And that looks different than ours, but now here, incorporate an Oculus utilities package. Even if you don't have an Oculus, we're going to eventually get to that, but don't worry about that for now. I've installed it. Reason why is parts of it doesn't work. So with a new version of Unity, I need to do some playing and figure out what's the new way that it goes. Now with our packages, what it looks like is, let's see, I imported a package, custom package. And here's the Oculus utilities that I had downloaded. And just like what we've been looking at, remember we brought in a lot of meshes that we could work with and so forth. This brings in some items to make our coding easier. And I click import. And a new or OVR plugin is available. That's curious. I said yes before. I'm not sure why it's asking me again. Let me say yes again. It's been updated again to 1.28. I wonder how many times. Maybe because I brought the package in again. Okay. I'm really wondering if I could I'll have to explore that concept to see if you can take the if there's some way to set up the camera such that it interfaces with the headset, so I could show you what appears. I mean, you could hold it up there, but it seems like there would be some way you could demonstrate it. But anyway, notice I have an Oculus asset here now. VR. It's got different items. Again, these are meant to meant to make your programming easier. For example, if I go into prefabs, you see here, this is our track remote. This is what I think that portable headset that Oculus Go has, if I remember right, has that controller. So if you're trying to program that, then they've already got this set up for you, so you can work with that. A camera. A camera is not the same principle in a 3D game as it is here. So you got your own camera rig, and you can drag and drop that up there, and then remove the other camera. And then when you play, of course we don't have anything here, but this would now be based upon the camera that's specifically designed for virtual reality. Now if I drop a, let's see, a game object, 3D terrain, and do a create material. And change it to green. Oh, well, let me drop it on there. That's disappointing. I was wondering if I could drop that on there, but let me see. Where's my paint at? Paint, and create a layer, and drop my green on there. Maybe it has to actually be an image. No, well, let me drop that. Let me put an image on there. Grass. Okay, one more time. Okay, there I got grass. And you see when I play this, I don't actually see my grass. So with our controller for the camera here, you may find you have to do different changes to it. Now, if we had this hooked into a headset, and we're doing our testing, then you can move that around and you can locate things easier. Am I still there? I see it. Does that make sense on the difference between how we did it before with the camera and how the camera is now your head?
Yeah. Yeah.
Get that to go off. So same principle, just the programming is different on it and different things you have to consider. You notice here in our tracking space for a camera rig, you got your left eye, anchor, center eye. Didn't know we had 3 eyes. But we got that for programming purposes. Right eye anchor, tracker anchor, left hand anchor, right hand anchor. Because again, different parts will control the camera in this. Instead of doing everything from scratch, we're going to use these built these items that are already built for us. See if there's anything else worth mentioning here. Notice here we have a lot of script that's already written for us. Because again, the idea is that we don't want to recreate everything. They already got some code already written to handle different events and so forth. You can see here it'll describe what it does in some cases. Provides a unified input system for Oculus controllers and gamepads. So if I bring that up, got a lot of stuff already defined for us. See a gamepad here. More of gamepad touch. Think how long it would take us to program all this in. That's the beauty of object-oriented programming. Is you build this object and you can drop it in to whatever game you're working, and you can use all this existing code. You don't have to write it all from scratch. Scenes. Let me double click the room. So it gives us that view there. Trivial. Cubes. Again, the idea in this is just kind of looks like standard to what we've seen already. But if we had our headset on, we could like have your hand come up type of deal if we had everything configured. Now they had some interesting items on here that I haven't explored. Go back to my sample scene. And see, they have the Oculus Go controller, some materials go along with that, and then the Gear VR controller. Probably all the interesting stuff. Android Manifest. Okay. Now, if you were to go to this website, and this is the part I had to play with this weekend. Open a web browser and navigate to this. Assuming you'd actually open it. Copy link address. That's nice. They have a lot of different options here because they figure you could be programming in Unity or any of these other options like Unreal Engine. These, I'm not sure what package that is. Unreal I've played with before. But if I click Unity, you'll see that they'll provide a lot of tools that you can use, audio, Unity integration, I think is the one I chose. This is the new version. I downloaded the older version. So this is the part that I'm going to install over the weekend. I went down here to the bottom where it said Oculus Utilities for Unity because I wanted to match the book. But matching the book doesn't mean anything if it doesn't work. This is version 1.28. And you can see it's not too old. 8/16, 2018. But things are changing so fast on these that this is considered your legacy stuff now. This talks about after you download that, you choose Assets, Import Package, Custom Package. You do the same thing we did on that standard Assets when we bring it in, where we import everything. And I'm probably not going to go into any more detail on that. Because like I say, I have to get it actually working before I can do that. But let me show you how to enable something for VR. If you go to File and Edit Project Settings. Under the player here, you're going to see some different options. Icon, resolution, presentation. The last one is XR settings. And you see down here, virtual reality supported, and so you put a little check mark there if it isn't already checked. And it specifically talks about the Oculus here, where you can check those. You can do a plus here, choose some other options, but these are the ones we're looking for. Mine was set up by default, and I don't know if that's because it automatically changes that when you bring in that package. The book implied that I'd have to actually set this, but I didn't have to. But anyway, that's how you configure it for the virtual reality. Now I'm just going to talk a little bit about do a new project. A little bit about the some more features of Unity, not related to the virtual reality. We'll kind of cross over on some different topics. A lot of this is geared around the design concepts. This book here is not really designed for teaching you working with Unity, C Sharp, so forth. It's more geared toward the design aspects. Although it does have code in there, because it has to. Okay. I'm going to drop a cube on here to do a game object. And drop on a cube. And currently this is at 0, 0, 0. There's a edit snap settings down here. And this is kind of useful. If you're moving this and you want to always be at certain values, you don't want decimals. You want it to go by ones. Then, if you, and I brought this up here just so we can see the values. If you hold down your control key, and we got the move tool selected, when you click with your left mouse button and grab that and start moving it, it goes by ones. So instead of going by decimals. We've been doing movements, and then we go up here and modify it, especially the rotations, because I want it to be rotated exactly so it's standing up straight. Well, this is another way you can handle those. Y's, Z's, you can have this go by whatever value. The rotation is how many degrees it changes. So here, if I put 30 degrees, then if I choose to rotate, hold down my control, you can have it change by 30 degrees. And there it just went to 30. If I hold down it again, it now changes to 60. So it's now at 60 degrees. So that's a snap setting. That's a control. We do a couple of Control Z's. We also have a way to work with the vertices, which we looked at. They're not just gear stopping at like the house and the terrain we looked at last time. There are any objects you have on here. Drop another cube on there. Move that out like that. If I hold down the V, remember these little white squares appear? When I become on this vertex, I can click and hold down and snap it up against that one. So you can bring those right together. We've already seen that. Remember, F is how you set your focus. There's also the rectangular tool here, where you can increase the size of that. Again, if you don't got it quite right, maybe it don't snap like that. You can always check it later on. Like my Y looks like it's 0.965. I'm guessing it should be 1. So that is 1. So the fact that you're using some of these tools doesn't get rid of the fact that it's really easy just to enter numbers in here. Okay, so I'm going to delete that cube. And we're going to take a look at another way to cause this to move. So I'm going to drop a script on it. So I'll click it over here in the hierarchy. I'll click the Add Component, New Script. And I'll call it Movement. And I'll do a Create and Add. It drops it here, and we've been double-clicking it here, but you can also double-click it over here. I'll bring it up. Now our update is again where it moves per frame. So I can say transform dot rotate. And XYZ, what do I want it to go around? I think that's what the last example did. That showed another other class. Attach that to Unity. And now if I play it, see how it goes around like that. Now, depending upon our frames per second, remember we can click stats to see that. This is based upon the frames. And so if you're running it on a slower machine, if you have a machine that has less graphics capability, some kind of hardware difference, you may see it not be realistic. It may not go right around at the right speed. Let me stop that. Drop another cube on there. And that one I'm going to drop a script on. So say add component, new script. Call it rotating. And double click it. Maybe. There it goes. I can have this one rotate around. So transform.rotate. Now let's see if I can remember the syntax here. I think it's 5 times time dot delta time 0. Now what this is going to be based upon is this 5 here. Let's see, around the y-axis. That rotates around the y-axis. That 5 represents degrees. And when you do that times time dot delta time, this throws in the actual time that's elapsed. And so this will actually go 5 degrees per second. So if I attach that, so now if I run those, maybe I'll help if they word. Okay, let me move that a little bit. Move one of them to the side. There we go. You look at this one in the back, and it's going slow. Specifically because it's moving 5 degrees per second. So in 60 seconds time, 1 minute, it'll move 300 degrees. Does not matter what machine that's running on. That will move 5 degrees per second. This one is moving 5 degrees per frame. So each time it goes through the update, it's doing this 5 degrees per frame, and it's moving like that. What's your frame? How long does it take? Well, I don't know. Again, it depends upon the machine. So that's why, to get a more consistent look on all different machines you might design this for, using that delta time is a preferred way. Now, you're not limited to just doing the rotation. You could do your, I think it was move. That or translate. Translate. 0.050. This right here, if I put an F on there, this is going to move 0.05 up every time a frame occurs. Again, this is not taking into account the different machine types. Oops. Okay, let me get back there. You see that's going up like that. Taking into account all the time. Transform dot rotate, and 0.5 F, guessing, time times time, delta time, 0. Was it 0.05 or 0.5? No, 0.05. I'm just demonstrating to you here the difference between them. It's going up slowly. Again, this is, I think it is. Yeah, it is. My eyes aren't that good. This demonstrates the difference between those. The one is going up at a distance of 0.05 for each frame. The other one's going up a distance of the 0.05 for each second. Now you can modify these however you want. Instead of going up by a second, you could multiply this times 60, divide by 60. So a lot of different options you have. You see, this says the time in seconds it took to complete the last frame. So if you have 5 seconds, if you divide by 60, that give you a number of minutes. If you multiply times 60, then it gives you a finer level, and so forth. Now you can program different items in here. So you're not restricted to... I did a rotate, didn't I? My eyes were off. I was thinking it was moving. Let's try that. Okay, now maybe I'll see it. Okay, yeah, it's definitely going up now because it's in a blue, the light blue. Now you can program this with movement. So you can do a if input dot you notice that there's other items I could program. Get mouse button down, mouse button up, get touch. We're going to be playing a lot more with those different options, especially if I get a joystick. Then we'll take a look at that. You can detect if a mouse is present. That's probably a true or false if I had to guess. Boolean. Yeah, so it's true or false. So I'd first check to see if mouse is present. And then if it is present, then I could do one of these other ones. Is there a mouse wheel? Get mouse button. Let's see if I can remember this. Button dot. Surely there's a way to. I don't have to actually put 0 and 1 in there. Okay, let me put a 0. Then I'm going to do my transform dot translate. And put in 0.5. So I'm going to make that a float. If I want to make it realistic, again, I'd multiply it times my time dot delta time, but I'll go with that just because I want to demonstrate this. Attach that to Unity. Now I don't know which 0 is. I'm guessing it's my left mouse button. Yep, it's my left mouse button. The other one would be my right mouse button. So if I did a 1 here, usually they provide some kind of user-friendly enumeration, so you don't have to sit there and remember 0 is the left mouse button, 1 is the right. What if the mouse wheel is like 2 or 3 something? Okay, so the 1 is my right mouse button. I better stop after this because I got to talk about the project. Yep, that's the mouse wheel. Because the question becomes if I just move the mouse wheel, or do I have to click it? Nope, moving it doesn't do it. Is there any questions on incorporating those into like a game?
Nope.
No.
Just a different way of thinking of it, based upon changes from where you're currently at. Has nothing to do with your absolute positioning. It's just a change from where you're currently located at, which is in reality the way that we want our games to work. We don't want our characters just to always move straight along the x-axis, along the y-axis, along the z-axis. We'd like our changes to be based upon the current location of that character. Okay, let me bring up the game. This is our 3D Space Invaders. And I'll put this due date out for a couple weeks, so you have time to work on it. Remember our 3D Space Invaders? Have our characters moving across and so forth. We had our array of prefabs here. And I went through in the other class and I documented the code pretty good, so you know which code is which. Now I'm going to give you access to the code, so I'll upload that. So you're welcome to edit, copy it, and edit, paste it direct. You don't need to give me any kind of credit on that or anything. And what I want you to do is I want you to develop your own character, your own alien, or you can get one from TurboSquid. That's up to you. I want you to come up with your the array of prefabs. So to begin with, focus on getting the array sitting there, and do it in pieces. So you get the array of prefabs appearing on your screen, then move them, and then put the bullet code in. So don't try to do it all at once. All at once, all of a sudden you got a bunch of errors maybe, and you got nothing working. So handle it a chunk at a time, and that way you'll understand better what each individual code's doing also. Now, in an ideal world, I just want you to basically recreate that 3D Space Invaders. But if you have time, want to go beyond that, that'd be fantastic. And perfect game, we would put houses here in the front or some other kind of object, and then our character could go behind that, and the aliens would be firing at us. And if they're bullet that they're firing at us, and not every alien fires in the 3D Space Invaders, or the game would be over in 2 seconds every time. But if that bullet that they're firing at us hits us, then the game's over. If they keep coming closer and they touch the house, well, the house is destroyed in the game, I think. It's been a while. But if they keep coming closer and the aliens touch you, then that means the game's over. The way it's set up now, there's no way you could lose that game because I have too few on there. So again, plan the correct number of aliens there. Make it a halfway playable time-wise. Questions on what I'm looking for?
No.
Okay. I'm going to go ahead and save off the recording here.